Hello. Alright, so this is the tutorials for 7-2 Pythagorean Theorem and its converse. I asked you guys to do the odd questions, so I'll do the even. I'll do every other odd. Okay, so number 1, find the value of x. We have a little triangle here. It has dimensions 8, 6, and x. So we're going to use the Pythagorean theorem for this. A squared plus b squared equals c squared. So a squared and b squared, those are going to be our legs squared. So it'd be 6 squared plus 8 squared equals c squared. That's 36 plus 64 equals c squared. That's 100 equals c squared, and then we take the square root of that. C must be 10. Notice when you take a square root, you get a positive and a negative number. However, in this case, we must have a positive number because there's no such thing as a negative distance. So C is equal to 10. Is this a Pythagorean triple? Yes, it is. Alright, so that was number 1. Let's move on to number 5. Alright, so this time you're given C. C is 97, and we want to find out one of the legs. One of my legs is 72. I don't know what the other one is. So, again, I'll write out the formula. A squared plus b squared equals c squared. I'll let 72 equal a. So 72 squared plus b squared equals 97 squared. Use a calculator for these. I don't know these off the top of my head. 72 squared is 5,184. 97 squared is 9,409. Now we're going to solve for b. So I'll subtract 5,184 from that side. So that's 4225 is equal to b squared. And then I take the square root of each side. B is equal to 65. So x equals 65. Notice I called it b here, but I'm calling it x here. It's the same thing in this case. I'm just saying b because that's the letters that are used in the actual formula. Okay, but we are solving for x. Alright, number 9. Okay, does each set of numbers form a Pythagorean triple? Explain. The numbers are 15, 20, and 25. The way to do these, you just run them through the Pythagorean theorem. This will be 225 plus 400 equals 625. And since this is true, they do form a Pythagorean triple. Okay. So if it weren't true, then they would not form a Pythagorean triple. So in this case, it did work. I believe, let's see, number 7, it does not. Okay, so number 7 does not form a Pythagorean triple. Alright, let's move on to 13. This is find the value of x, leave it in most simple radical form. Okay, so we're going to use the Pythagorean theorem again. So this would be 10 squared plus 16 squared equals x squared. That's 100 plus 256 equals x squared. So that's 356 equals x squared. Now this is how these differ. Instead of using a calculator to square root this, what I'm going to do is I'm going to break this apart using a factor tree, and then I'll apply square roots of squares, so it makes a nice even number, and my answer will be something in the form of a whole number, like say 3 or 4, times a radical. So that's square root of some number. That's what a radical is. Alright, so this is 356. It's an even number, so it's going to be divisible by 2. So 356 divided by 2, that's 178 and 2. Again, we have another even number. So I can divide by 2 again. Get 89 and 2. 89 is a prime number. Okay. Another way to do this is to divide this number by squares that you know. So in this case, I could have just done it by 4 to get 89. Let's see if it'll divide out by 9, which is our next square. It does not, so that does not work. Does it divide out by 16? No. 25 would not work. 36? No. So what numbers I'm dividing by are 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16. 5 squared didn't work. I can already tell because 5 can only go into either a 5 and a 0. 6 squared is 36. That doesn't work. Let's try 7 squared. That's 49. That doesn't work. 8 squared is an even number. We can try that. That doesn't work. Okay, so the chances are getting pretty slim at this point. Let's do 9 squared. That doesn't work either. 10 squared is 100. That won't work. Let's do 121. Not going to work. Okay, so at this point we're done because 89 is a prime number, meaning it is only divisible by itself in 1. So 356 is equal to 89 times 2 times 2. Okay, since I have 2 2's, that's 4. So this is 89 times 4. I can take the square root of 4. That's 2 on the outside of that square root. So my answer is 2 times the square root of 89 is equal to x. Okay. Let's move on to the next one. Number 17. A walkway forms a diagonal of a square playground. Okay, so I have a playground here. A walkway forms a diagonal. A diagonal goes right across the two corners opposite each other, kitty corner. The walkway is 24 meters long. The nearest tenth of a meter, how long is a side of the playground? So this is my side. Alright, so this is a square. That means that x and x are the same, so it doesn't matter which one. They're both the same, since all the sides are the same in the square. So I can set up my equation x squared plus x squared equals 24 squared. I have 2 copies of x, so that's 2x squared equals 24 squared. Let's take care of this 24 squared. I'm going to multiply that out. That is 576, so 2x squared equals 576. Next I'll divide out by 2. So x squared equals 288. And then I'll take the square root of that number. So it's this, the nearest tenth. I get 16.97, which rounded up to the nearest tenth is going to be 17.0. Our answer is 17 meters long. Alright, that was number 17. Next one. And I feel I need to do number 19 since it's the only one in that set. Number 19, find the area of each triangle. Leave your answer in simplest radical form. So we're given a triangle here. Don't know the height. I will need to know the height though, because area is base times height. 1/2 base times height for a triangle. So I need to solve for this leg here. Okay. So this is, okay, according to the, what theorem was it? Perpendicular bisector theorem. of a segment. So since these two legs are the same length, that means that this perpendicular bisector will cut this segment in half, meaning that this is 6 and this is 6. So to solve for this leg here, we'll call it x. My leg is x squared plus the other leg, 6 squared, equals 8 squared. So x squared plus 36 equals 64. 64 minus 36 is 28. And then leave your answer in the simplest radical form. Okay, so we need to take the square root of this and leave it in simplest radical form. So let's try 4. I'm going to take a 4 out of here. So I have x, the square root of x squared is equal to 4 times 7. 4 is a perfect square, so that actually comes out. So x is equal to 2 root 7. Okay, we're not done. So I need to take this. This is x. This is my height. I'm going to plug it into the area equation. So the area of a triangle is equal to 1/2 base times height. My base is 12. Got something in my nose. My height is going to be... Oh, stupid thing. Sorry. My height is going to be 2 root 7, that's x. So the 2's will cancel out. Area is equal to 12 root 7 centimeters squared. There you go. And then number 21 I'll do. Is each triangle a right triangle? Explain. Okay, so it's a right triangle if a squared plus b squared equals c squared. And that's the only way. So let's do 20 squared plus 19 squared equals 28 squared. Okay, is this true? I can calculate at time. 20 squared is 400. 19 squared is 361. So together those equal 761. 28 squared is 784. Okay, so they do not equal each other. So since this is not true, this is not a right triangle. In fact, this triangle is obtuse, since the c squared is larger than a squared plus b squared. Let us move on. Let's go on to 25. Okay, it says the lengths of the sides of a triangle are given. Classify each triangle as acute, right, or obtuse. Okay, so according to our notes, if a squared plus b squared equals c squared, then it's a right triangle. If a squared plus b squared is greater than c squared, then it's acute. So it looks something like this. These are our sides, a, b, and c. And then the last one, the last case, if these guys are less than c squared, then it's obtuse. This is the case where c is very large. Okay. This is an obtuse triangle. Obtuse meaning that it's got an angle greater than 90 degrees. So 25, our numbers are 12, 16, and 20. I believe this is a Pythagorean triple. Let's go ahead and figure this out. So I'm going to plug in 12 squared plus 16 squared is equal to 400. Let's see what 20 squared is. 20 squared is 400. So this is case 1. A squared plus b squared equals c squared, so it's a right triangle. This is a right triangle. Let's look at number 29. The numbers are 11, 12, and 15. My hunch says that this is acute, so I'm going to plug in some numbers here. 11 squared plus 12 squared is 265. So this is 265. 15 squared is 225. Okay, so notice how a squared plus b squared is greater than c squared. So this is going to be an acute triangle. Okay, that was 29. Let's do 33 next. We have 31, 23, and 12. Okay, it's trying to trick you. These are written out of order. The hypotenuse is always going to be the largest side. Okay, so this is your A, this is your B. Let's do 23 squared plus 12 squared. That's 673. And then 31 squared is 961. So c squared is much larger. Is much larger than a squared plus b squared. So we have the case of the obtuse triangle. This is obtuse. Some of these, like number 33 for example, it gives you stuff like the square root of 11, the square root of 7, and 4. If you square a square root, it just equals that number inside. So the square of the square root of 11 is just equal to 11. I hope that helps. Alright guys, that's it for these. Have fun. See you guys.